Hello, friends. Welcome to Akulmike Live. The today that we have in our mind and that we want to discuss with you is: are we truly alone in the universe? In this video, we will explore the concept of the Solitude Zone, a hypothetical region of the space where civilizations are incredibly rare or non existent. We analyze the latest scientific data, including the observations from the James Webb Space Telescope, to investigate why our corner of the cosmos might be a cosmic island. Let's go. Friends, look up at the night sky. On a clear moonless night, you might see countless stars, perhaps even the faint Milky Way band of our own galaxy. And we call it fondly the Milky Way. Each of these pinprick of light is a sun, many of them far larger and brighter than our own, and orbiting countless of those suns are the planets. So many planets that their number defies human comprehensions. Here we are on Earth, a small blue marble teeming with life. From the simplest bacteria to most complex creatures, life have found a way to thrive here. For centuries, perhaps millennia, humanity has asked one of the most profound questions imaginable. That is, are we alone? The universe is incomprehensibly vast. Our own galaxy, the Milky Way, contains an estimated 100 to 400 billion stars, and there are at least 2 trillion galaxies in the observable universe. The sheer scale suggests that life, perhaps even intelligent life, should be very common. Yet, here we are, still listening, still searching, and so far, complete silence. This silence has led some to ponder a disturbing concept, that is, what if we reside in what we might call the solitude zone, a vast lonely void where intelligent life, if it exists elsewhere at all, is so incredibly distant that its presence is effectively undetectable. This brings us directly to one of the most perplexing questions in science, the Fermi paradox, named after the physicist Enrico Fermi, who during a casual lunch conversation in the year 1950 famously asked, "Where is everybody?" On one hand, numbers are staggering. Billions of stars, billions of potentially habitable planets. Given enough time and opportunity, life should arise. Given even more time, intelligent life capable of interstellar travel or communication should evolve. If even a small fraction of these planets harbor such civilizations, our galaxy alone should be teeming with them. They should have spread, colonized, and left undeniable signs of their existence. So, where are they? Why haven't we heard from them or seen their probes or witnessed their megastructures? The absence of evidence in this case is so profound that it compels us to look for explanations. And these explanations often fall into two broad categories. Either they don't exist or we simply haven't found them yet for reasons we can't explain. One of the most sobering proposed solution to the Fermi paradox is the Great Filter. This theory suggests that at some point in the evolution of life form, the very beginning to advanced interstellar civilization, there is an extremely challenging, perhaps insurmountable step that very few, if any, species can overcome. This filter should be behind us, meaning we got incredibly lucky, or more terrifyingly, it could be ahead of us. If the great filter is in our past, it means that the development of intelligent technology, advanced life, is far from improbable than we imagine. Perhaps the leap from non living matter to self replicating life is incredibly rare. Or the evolution of complex multicellular organism, or maybe the emergence of tool using intelligence Language and the abstract thought is a truly unique bottleneck. If this is the case, then Earth is an astonishing anomaly, and we are indeed a cosmic solitude, living in a zone which is, kind of a alone, because no one else made it this far. But what if the great filter is still ahead of us? This is more chilling possibility. It suggests that while life might be common, almost all civilizations eventually encounter an existential challenge they cannot overcome. This could be self-destructing through nuclear war, environmental collapse, a runaway artificial intelligence, or perhaps a cosmic catastrophe like the gamma ray burst, or a rogue asteroid impact that wipes out almost all life in the star system. If this is true, then the silence isn't because no one ever arose, but because they didn't last. Our own future might be precarious. Beyond the great filter, let's consider the conditions for life itself. For decades, our understanding of habitable planets was largely based on our own Earth. We looked for planets in the Goldilocks zone, not too hot, not too cold, where liquid water could exist. We now know that universe is teeming with exoplanets. The Kepler Space Telescope alone identified thousands of them, and missions like TESS continues to find more. We discovered some super Earth, mini Neptunes, and planet orbiting all sorts of stars. The most common star in our galaxy are the M dwarf, smaller, cooler than our sun, but potentially hosting many habitable zone planets. However, simply being in the Goldilocks zone might not be enough for complex intelligence life to evolve. Earth benefits from suite of unique characteristics: a relatively stable, long-lived star, a protective magnetic field, a large moon that stabilizes our axial tilt, preventing extreme climate swings, and plate tectonics, which recycles nutrient and regulates our planet's temperature over geological timescales. Are these factors common, or are they too incredibly rare? Even our solar system's architecture seems to play a role. The presence of gas giants like Jupiter acting as gravitational big brother may have shielded Earth from countless comet and asteroid impact that could have sterilized our planet during its formative years. The formation of complex planetary system that balances these factors for billions of years might be the true rarity. So if they are out there, where are the signals? This brings us to the search of extraterrestrial intelligence, or SETI, SETI. For decades, projects like SETI has been scanning the skies, listening for an artificial signal that might betray the presence of an alien civilization. We mostly listen for radio waves because they travel at the speed of light. Are they relatively easy to generate and also can penetrate cosmic dust and gas? But even with our most sensitive instruments, the sheer volume of space is overwhelming. Imagine trying to find a single radio station on Earth but without knowing the frequency, the location, or even if it is broadcasting at all. And from a distance of millions of light years, it is a daunting task. Furthermore, what if alien life doesn't communicate in a way we can detect or understand? Perhaps they use neutrinos or gravitational waves, or form of communication we haven't even conceived yet. Our search is inherently anthropocentric. We look for what we understand. Recent advances, particularly with telescopes like the James Webb Space Telescopes, are revolutionizing our ability to study exoplanet atmospheres. By analyzing the light filtered through an exoplanet atmosphere, scientists can detect biosignatures, chemical indicators like oxygen, methane, or ozone that might suggest the presence of life. This is a game changer. Instead of just looking for radio signals, we are now actively searching for the fingerprints of life itself. But even with this incredible capability, the distances are immense and the subtle clues require extraordinary precision and patience. It's like trying to detect a scent of a single flower from across the continent. Let us consider another aspect, the scale of time. Civilization might arise, flourish, and disappear over cosmic timescales that are utterly insignificant to us. A civilization might have existed on a nearby star system a billion years ago, or they might emerge a billion years from now. In either case, we would never know. Our window of observation is very, very small. This also applies to our own potential broadcast. Our earliest signal radio transmissions are only about a century old. They have traveled about 100 light years but out in the space, a tiny bubble in the vastness of our galaxy. Anyone listening beyond that bubble wouldn't even know we exist yet. And for our signals to be strong enough to be detected, they need to be powerful, directed, and lucky enough to hit an alien receiver. Then there are more speculative solutions to the Fermi paradox, often referred to as they are here or they exist but are hiding. This range from zoo hypothesis where advanced aliens are deliberately avoiding contact with us to allow us for our natural and so that they leave us alone and develop naturally, treating Earth like a protective wilderness reserve. Or perhaps advanced civilizations simply evolved beyond our understanding. They might not use radio waves or even physical bodies. They could become entirely digital, transcend to higher dimensions, or have such different motivation that they have no interest in communicating with nascent civilizations like ours. They may be everywhere, yet utterly undetectable to our current methods. If they are so advanced, why would they care about us? A species still grappling with our own planet. So, where does this leave us as regard to the solitude zone? The idea that we are fundamentally alone in our immediate cosmic neighborhood, not necessarily because life is utterly unique, but because the odds of intelligent, detectable life exist at the same time and close enough to us are astronomically low. It's not about being the only life in the universe, which is much bolder claim. It's about being in a region where the distances are so vast, the conditions are so specific, and the timelines so disparate that the effective experience is one of the profound solitude. We are on a cosmic island, perhaps one of many, but surrounded by oceans of dark, empty space that will likely never be traversed by another intelligent species in our own lifetime. This idea can be unsettling. It forces us to confront our own significance or lack of thereof, or uh, we will never see an alien on a universal scale. If there is no one out there to save us or even to inspire us, then our fate rests solely in our own hands. But the concept of solitude zone also carries a powerful message of hope and responsibility. If we are truly rare, our existence in cosmic miracle, then it makes our civilization, our planet, and indeed all life incredibly precious. It underscores the urgency of preserving our home, resolving our conflicts, and ensuring the long term survival of our species. It also ignites our drive to explore, to discover, and to understand. The search continues not just for others, but for a deeper understanding of ourselves and our place in the universe. Every new exoplanet discovered, every atmospheric analysis, every radio signal listened to pushes the boundary for our knowledge. The universe is vast and mysterious, and our current understanding is but a tiny glimmer in its boundless dark. We may be in the solitude zone for now, but that doesn't mean we are without a purpose. It means our purpose is uniquely ours to define. The question, are we alone, might remain unanswered for centuries, perhaps forever, but the journey of asking, of searching, of contemplating the lonely void is what defines us as intelligent, curious, and resilient species. So, friends, what do you believe? Is the universe teeming with life, or are we truly isolated in our own cosmic corner? Share your thoughts in the comments below. Thank you for joining me live. Thank you for watching. This is exploration of the lonely void. If you enjoyed this journey, please like this video, subscribe to our channel for more cosmic insights, and hit that notification bell so you don't miss out our next adventure. See you in the next one.